Okay, so I've had some questions about how to figure out the percent composition of a compound. Like, for instance, like if I'm looking at a compound, aluminum carbonate, or Al2 parentheses CO3 parentheses 3, and I ask a question like, let's figure out what the percent composition of aluminum is in that compound. And so the way I would do that is I have to figure out what the molar mass of each individual element is and figure out what the total molar mass is and compare it to the individual element's molar mass. Like, for instance, in this case, I would want to compare aluminum's individual molar mass in this compound to the overall molar mass of this compound. So I'll walk you through what I'm going to do. So I'm just going to start with aluminum, and I'm going to look on the periodic table to figure out aluminum's molar mass. When I find it on the periodic table, you're going to find it has a molar mass of 26.98, which I'm just going to round to 27 grams per mole. And notice that there are 2 of them in the compound, and so therefore I'm going to have to multiply that by 2 because I've got 2 atoms of aluminum. And so when I do that, you get 54 grams per mole, and that's the molar mass of the total amount of 2 aluminums in that compound. I've got to continue that with the carbon, and that's what we talked about on Friday. When I have parentheses like this, that basically is telling me that 3 on the outside of the parentheses is telling me that I have 3 sets of these CO3 combinations. And so therefore I've got 3 CO3s. So if I got 3 sets of CO3s and I have not 1 carbon, but I have 3 of them, basically I distribute that 3 in. In carbon, if you look on the molar mass, on the periodic table, it has a molar mass of 12 grams per mole. And so therefore, because I'm distributing it through, I'm going to have 3 atoms of carbon in that compound. And so when I do that, I'm going to get 36 grams per mole, which is the total molar mass of 3 carbons in that compound. Finally, I've got my oxygen. Each oxygen has a molar mass of 16 grams per mole. And I have not 3 of them, and not 6 of them, but I have 3 sets of O3. So therefore I would have 3 times 3, which would be 9 total oxygen atoms in that compound. And if I multiply those guys together, I'm going to get 144 grams per mole. So therefore I can see that 9 oxygens in this compound account for 144 grams per mole. Well, to find the total molar mass, I just simply need to add these guys up. And when I do that, I should get 234 grams per mole. So this right here is the total amount. Let me see if I get a little bit clearer image there. Down there is the bottom total amount of molar mass right here, and this is the individual from each one. So now to find the percent composition of aluminum in this overall compound, what I want to do is I want to take the aluminum's molar mass, which is total in the compound, 54, and I want to write that as a percentage, 54 grams per mole, over the total amount of molar mass, which is that 234 grams per mole. And then to make it a percent, I'm just going to simply multiply by 100. When I do that, you should get about 23.1%. So what that's saying is, in this compound right here, by mass, aluminum accounts for 23.1% of the overall compound. Well, if I wanted to, I know I didn't ask for it, but if I wanted to figure out the percent composition by mass of oxygen in this compound, I'd simply take 144 grams per mole, because that's how much total oxygen is in that compound, over the total molar mass of the compound, 234 grams per mole, and I multiply that by 100, and then you get an answer. So that is how to figure out percent composition given the formula.